Welcome to all. In this video, now we are going to see DC to DC converters. We already know some of components like rectifier, inverters like that. And rectifier is nothing but converts an AC voltage into a DC voltage, whereas an inverter converts a DC voltage into an AC voltage. Here, it converts an DC voltage into another form of DC voltage. Sometimes these converters are also called as choppers. There are three types of converters like buck converter, boost converter, then the buck boost converter. This buck converter is also called as step down converter. That is nothing but when you compare its output voltage with its input voltage, then the output voltage will be very less when compared to the input voltage. Same when you compare to the boost converter, this is very contrast to the buck converter. Here when its output voltage will be much higher when compared to the input voltage, hence it is called as a step up converter. Then third form of converter is nothing but buck boost converter. Here it will act as either step up or step down converter. That is nothing but it will either increase or decrease its output voltage when compared to the input voltage. Now we are going to see buck converter. When you compare its output voltage with its input voltage, it will be much larger. Hence, this type of converter is also called as step down converter. Sorry, this output voltage will be very less when compared to the input voltage. Hence, it is called as step down converter. It finds applications in like CPU where some different parts requires different voltages. Some parts requires very less voltages. From in that cases, this buck converter will be applicable. Now we are going to see the diagram for the buck converter. Here there is input voltage, there is an PN junction diode, then there is an inductor and the capacitor. Here we already know that both the capacitor as well as inductor both are the charging devices, but the inductor charges in the form of magnetic field, whereas the capacitor charges in the form of the electric field. When you apply the voltage, this S is nothing but a switch. This switch it can be either a transistor or a MOSFET. In this case, let us consider there is a BJT transistor is there. Here we are going to see two cases. In first case, when we consider the switch is on and then the supply is given to the circuit, then the current will flow through VI, then through inductor, then through load, then again to the power supply. Here the diode is in reverse bias because when the switch is connected, the inductor positive is given to the reverse bias junction of the diode. Hence, that is the positive voltage is supplied to the reverse. That is the cathode terminal. Yes, the diode will become reverse biased. We already know that when a diode is in reverse biased, then it will not conduct the current. Therefore, it will be a open circuit. Therefore, when the switch is on, then the supply voltage will be given to switch, then inductor, then the load, then again to the input power supply. In this case, the inductor will be charged on when charged according to the input voltage. So simply we can say that say this: when switch is on, then the inductor gets charged. So in the second case, where after some time, then the switch gets released. Therefore, the circuit becomes open circuit. In this case, the whatever the charges which is charged in the inductor will be discharged through this loop, because this cathode terminal, this negative voltage will be given to the cathode terminal. That is forward bias. Here, and we already know that when a diode is in forward bias, it conducts. Therefore, the inductor discharges through this loop again to the load, to the switch, that is to the PN junction diode, again to the inductor. This process will be continued. We can simply here in the case 2 we can say that in case 2, when switch is off, that is when switch is released, the inductor discharges. Here the purpose of capacitor here is some noises will be present in the inductor voltage. That voltage will be here purified in the form of the capacitor. That is, the capacitor will act as a filter. Here the duty cycle is nothing but the value of T on divided by T on divided by T off. That is the total time, the on time plus off time divided by the total time, T on time, total on time. So when switch is on, the input voltage will be present, whereas when switch is then the input voltage will be neglected. Then by comparing these two equations, we will get the output voltage as V0 is equal to VA into T on divided by T. That is nothing but we are going to compare this first equation with this second equation. Then by taking the LCM, then we will get the output voltage as VA into T on divided by T. This is the waveforms of buck converter. This VA is nothing but the input voltage. That is the input voltage. T on means the pulse will be given. When the time is T off, there is zero voltage will be given. On pulse and off pulse. When we measure the inductor voltage, when during the T on, that is nothing but the switch is on, right? When the switch is on, we already discussed it. When a switch is on, the inductor gets charged. Also, when the switch is off, that is when it gets open looped, now the inductor gets discharged. From this above theory, we can draw this waveform. During the T on, that is the switch is on, the inductor gets gradually charged. Then when the switch gets released, then the inductor discharges like this. Again, this will be repeated then during this T on and T off during the next cycle. This one cycle we are drawn for a two cycles. This one T on and one T off will make a one cycle. Another this T on and T off will make another cycle. So we are going to draw the waveforms for two cycles. When switch is on, the inductor charges. When the switch is released, the inductor discharges. This here ID is diode current. We already saw that when the switch is on, that is when there is a closed loop, the diode becomes reverse biased. Therefore, in reverse bias, the diode does not conduct. Therefore, when there is a switch is on, the diode current becomes zero. Whereas when the switch is released, that is the switch is on off condition, the diode gets charged like this. Again, when the switch is turned on, the diode becomes reverse biased, and when the switch is released, then the diode becomes forward biased. So this is about the buck converter. Thank you.